Pydantic AI employs dependency injection and structured output validation to create type-safe, observable agent workflows. The framework's agent class serves as the central orchestrator, managing LLM interactions, tool integrations, and runtime context propagation through a generic type system. We're about to examine how observability is added to this agent architecture using Logfire instrumentation. The setup will demonstrate SDK configuration, agent instrumentation, and database query tracing, all while maintaining the existing dependency injection and structured output patterns.
From Pydantic AI import agent, run context. From bank database import database con. Import Logfire. Logfire, configure #1. Logfire, instrument Pydantic AI #2. Logfire, instrument SQLite 3 #3. Support agent equals agent. OpenAI GPT-5 Deps type equals support dependencies. Output type equals support output. Instructions equals. You are a support agent in our bank. Give the customer support and judge the risk level of their query.
This code demonstrates how to add observability to a Pydantic AI agent using Logfire, a crucial step for debugging and monitoring agent behavior in production. The pattern involves 3 key instrumentation calls: Logfire, configure to initialize the SDK, Logfire, instrument Pydantic AI to enable tracing for all Pydantic AI agents, and Logfire, instrument SQLite 3 to capture database queries. This setup creates detailed traces showing message exchanges, tool calls, token usage, and latency essential for understanding agent decisions and optimizing performance. The instrumentation is applied globally, meaning all agent runs and database operations will be traced from this point onward. This approach is particularly valuable for agents like the support agent shown, where stochastic LLM behavior and tool interactions make traditional debugging ineffective. The trade-off is minimal overhead when Logfire isn't configured, as the instrumentation gracefully degrades to a no-op. In production, this observability becomes critical for monitoring costs, debugging issues, and maintaining reliable agent behavior over time. The code shows how observability integrates seamlessly with Pydantic AI's architecture, where agents are generic over dependency and output types. The support dependencies and support output types remain unchanged, demonstrating that instrumentation is a non-invasive addition. This pattern is especially useful when agents perform sensitive operations like banking support, where understanding decision paths and maintaining audit trails is essential for both development and compliance. Let's break it down.
From Pydantic AI import agent, run context.
Imports the agent, class, and run context type from the Pydantic AI package, providing the core components for building AI agents and accessing runtime context during agent execution.
From bank database import database con.
Imports the database con class from the bank database module, making it available for establishing database connections in this code.
Import Logfire.
Imports the Logfire module for observability and monitoring capabilities in Pydantic AI applications.
Logfire, configure #1.
Configures Logfire for observability by initializing its settings, enabling the collection of traces, metrics, and logs for monitoring and debugging purposes. This setup is required before any instrumentation or data collection can occur.
Logfire, instrument Pydantic AI #2.
Enables Logfire instrumentation for Pydantic AI, which will automatically track and record detailed traces of agent runs, including model interactions, tool calls, token usage, and latency metrics. This call activates observability features specifically for Pydantic AI components when the Logfire package is properly configured.
Logfire, instrument SQLite 3-3.
Enables Logfire instrumentation for SQLite 3 database operations, automatically capturing and tracing all SQLite 3 queries, connections, and execution details for observability purposes. This call configures the monitoring system to record database interactions without requiring manual instrumentation of individual queries.
Support agent equals agent. OpenAI GPT-5.2.
Creates an agent instance named Support Agent using the OpenAI GPT-5.2 model as its default LLM. The agent class serves as the primary interface for interacting with language models in Pydantic AI, and this specific instance will use the specified model for its operations unless overridden during runtime.
Deps type equals support dependencies.
Sets the dependency type constraint for the agent to support dependencies, specifying that this agent will use dependencies of that particular type during its execution. This parameter defines the type of dependencies that dynamic instructions, tools, and output functions can access through the run context.
Output type equals support output.
Sets the output type for the agent to support output, specifying that the agent's response must conform to this structured output type. This ensures type safety and that the LLM's final response will be validated and parsed as a support output instance.
You are a support agent in our bank. Give the.
Defines a string literal containing the beginning of a system, prompt for a banking support agent role, specifically stating, "You are a support agent in our bank. Give the." This appears to be setting up the contextual role for an AI agent's instructions, though the instruction is incomplete as it cuts off mid-sentence. The string would typically be used as part of the agent's instructions parameter to define its behavioral context.
Customer support and judge the risk level of their query.
This line describes the purpose of an AI agent in a customer support context, specifically to evaluate and categorize the risk level associated with customer queries. It suggests the agent will analyze support requests to determine their urgency or potential impact, likely as part of a triage or prioritization system. The focus is on assessing risk rather than providing direct solutions to the queries. The key takeaway here is how observability integrates seamlessly with Pydantic AI's type-safe agent architecture. The 3 Logfire instrumentation calls work together to create comprehensive traces without modifying the agent's core logic. Logfire, configure sets up the foundation, while instrument, Pydantic AI, and instrument SQLite 3 add agent-specific and database tracing respectively. This non-invasive approach preserves the existing dependency injection pattern and structured output validation, while adding crucial visibility into agent behavior. The trade-off is minimal overhead when Logfire isn't configured, making it production-ready for monitoring costs, debugging issues, and maintaining reliable agent behavior, especially important for sensitive operations like banking support, where understanding decision paths is critical.
The agent traces its steps, yet the logs walk away untraced.